This is example 4 on permutations and combinations. Your friend is having a game night party. He has 15 board games to choose from. There's only time to play 4 games. In how many ways can you choose which games to play? As always, we need to determine if this is a permutation or a combination before we start working the problem. And in order to do that, I like to place myself in the situation so that I'm better visualizing what's going on. So let's go to this party, this party at a friend's house. We get there and he has 15 board games out on the table, and we can't stay up all night playing board games, so we're going to choose 4 to play that night. Okay, so let's say I get to choose randomly 4 games. So they blindfold me, and it's fun, and okay, whatever you touch, that's what we're gonna get out of the pile, and that will be your game, and I get to do that 4 times. So I'm blindfolded and I choose these 4 games. Let's say this is board game, I'm just gonna call this, well, let's call it Monopoly. And then Clue, Trouble, and some checkers. Okay? And those are the 4 selections I made blindfolded. Now your friends, our friends, they see this selection and they're not happy with it. They're saying like, oh no, Monopoly, that takes forever. Clue, oh no, we don't want those 4 games. There are much better games on that pile than these 4. Put them back. Let's get someone else to choose. So they blindfold someone else and they ask them to choose 4 games, and this other person touches the checkers, Trouble, Monopoly, and Clue. Okay, now he selected the same 4 games you selected, just in a different order, but it's still the same 4 games. So you can tell that these 2 events that occurred randomly are identical events. In this situation, they are identical even though they are arranged differently, because you ended up with the same 4 games that that other person chose and nobody wanted to play. Okay, so that means that this arrangement, that second time, that doesn't count as a way of selecting 4 out of 15 because it's repeated. For us, they're identical. It's the same 4 games. Put them back, get someone else to choose, and let's see if they come up with a different selection of 4 games. Okay, so this tells me that the order does not matter. That means it doesn't matter what order you choose them in, they're still the same 4 games. So this means this is a combination. So this would be 15C4. And you already know what this is. 15 minus 4 factorial times 4 factorial. Okay? And you can do that in your calculator, or you can do it by hand, and we've seen how to do that in other examples. Now, I want to go ahead and go a little bit further with this problem and try and show you how this problem can turn into a permutation problem. Let's say I tell you that the order in which I choose the games is the order in which we're going to play the games. So let's say the first game you chose randomly, that will be the first game we will play tonight. The second game that we chose randomly, that will be the second game we play tonight, and so on. Okay, so if I say that and I ask you, in how many different ways can I choose 4 games out of these 15, then that's a different story, right? Because now let's use the same things that I drew here, these board games. If that first time I chose 4, the first game I touch is Monopoly, and I say, well, we have to play Monopoly first. And then I chose Clue, and then I said, okay, we're going to play Clue as our second game. Now we're going to play Trouble as our third game and Checkers as our fourth game. Okay? Now suppose I go back because I don't want to play Monopoly first. That's the longest one. If we start playing Monopoly first, we'll never get through to the second and third and fourth game, right? So we put them back. I'm blindfolded again. I choose 4 out of the pile. I end up choosing Checkers first. Great. We play Checkers first. That's a quick game. Then second option I chose is Trouble. That means we're going to play Trouble second, another short game, and then Monopoly is the third option, etc. Now, as you can see here, this arrangement here is very different than this one, because in this one the order matters. And we said that the first one I chose was the first one I was going to play. So how many different ways can I choose? Well, there are a lot, right? There are a lot of ways. This arrangement exists. This one also counts as different than this one because the games are not going to be played in the same order. So for that second example, I would have 4 permutation 15, 15 permutation 4, and that would be 15 factorial over 15 minus 4 factorial. And you can tell, since I'm not dividing by 4 factorial, this number is going to be bigger than the combination number. Okay, so I hope you understood the difference here between combination and permutation. I'll see you in the next video where we're going to do another example. And I think, yeah, we'll do another example. I'll see you then.